Hi everyone, my name is Alicia Lizarraga, and today's weekly presentation is based on the paper Effects of Breeding Density on the Total Length and Survival of Lake Sturgeon Free Embryos. This paper was written by John M. Bauman, Edward A. Baker, Terry L. March, and Kim T. Scribner. Following with the introduction of the study, this paper was based on the ancient species lake sturgeon, Accipenser fulvescens, which are very important to the ecosystem and are currently facing conservation challenges, meaning that they're going on decline. And due to this problem, a lot of aquaculture production programs have been working towards restocking and conserving these species. The objective of this study was to investigate the different rearing densities that could have an effect in total length and survival rate of lake sturgeon free embryos. The survival and growth during early life stages is crucial for commercial as well as conservation in aquaculture production programs. And so this research aimed to provide practical guidance for optimizing aquaculture practices to improve the total length and survival of free embryo stages. Study site and time. This study took place in a rearing facility called the Black River Streamside Rearing Facility in Black River, Sheboygan County in Michigan State. The initiation of this study was conducted in June 2013 and only lasted 9 days. The methods. A BRSRF flow-through system was used. The system was supplied with ambient river water from the Clever Reservoir, which was near the facility. The water temperatures used in this research range from 17.7 degrees Celsius to 20.5 degrees Celsius. And for the fertilization and incubation, gametes were collected from both females and males from two different families that were used to compare different data. Gametes were fertilized within 4 hours of collection at the BRSRF, and about 200 milliliters eggs per females were placed into separate dry bowls, and later on sperm was introduced, and these were activated using a 1 to 200 dilution ratio of ambient river water, which lasted 90 seconds for fertilization to take place. Later on, eggs deadhesion was done by applying Fuller's Earth solution, and these were carefully and very slowly mixed for 15 minutes. As soon as the 15-minute period was completed, the Fuller Earth was rinsed. After the Fuller Earth was rinsed, iodophil was used for disinfection, and later on rinse for 10 minutes with ambient river water. Once iodophil was completely removed, the eggs were then transferred to egg hatching jars for incubation purposes. After 2-day post-fertilizations, the eggs were treated daily with 500 milligrams per liter bath treatment of hydrogen peroxide for 15 minutes until the 24-hour prior to hatch. The eggs were also photographed with a ruler for scale and measured using image J version 1.43U. For the experimental treatment, 4 different rearing densities were conducted using free embryos. These densities were 50, 150, 300, or 500 offspring per 3.0 liter tank. The families were kept separated throughout the experiment to compare differences in body size and survival rates. After hatching, the embryos were placed into different tanks in regards to the families until 4 replicates of each tank density levels were filled. That came out to a total of 32 tanks. Water flow was kept at a rate of 57 liters per hour, and a 12-hour light to 12-hour dark environment ratio was used during the whole 9-day period of the experiment. If there were any mortalities present, these were removed and enumerated at the start of each rearing day. For the statistical analyses, they used different types of models. They tested for differences in mean egg size, mean total length at emergence, mean dissolved oxygen concentration, and mean proportional survival as a function of fixed effects, which included rearing density and family. Mean values were tested using SAS version 9.3, and the normality assumptions were assessed using the Zafiro-Wilk test. Homogeneity of variance assumptions were assessed using the Levenes test, and a p-value of less than 0.05 was considered statistically significant for all analysis. Comparison of mean egg size between families was done using a 2-sample t-test, and ANOVA general linear model was used to analyze total length at emergence and mean dissolved oxygen concentrations. A generalized linear model using a logit length function in ANOVA was used to analyze the survival data. For the results in different total lengths, in this table we can see the four ring densities regarding both of the families, family 1 and family 2, and we can see that total length at emergence decreased as rearing density increased. The mean total length of lower ring densities being 50 and 150 fish per tank was greater than those with larger ring densities being 300 and 500 fish per tank. And in this table we can see that the mean total length at emergence for family 2 was greater than family 1, and family 2 also had larger egg diameters as compared to family 1. For the dissolved oxygen concentrations regarding the different rearing densities in both families, we can see that dissolved oxygen decreased as the density increased. And in the table, we can see that the rearing densities of 50 and 150 fish per tanks were greater as opposed to those in the 300 and 500 fish per tank. There wasn't too much of a difference between both families, as we can observe in this table. And for this table, we can see the survival to emergence regarding the different rearing densities for both families. Survival rate also decreased as rearing density increased, and survival rates were higher at lower densities, but were not statistically significant, meaning that there wasn't much mortalities going on regarding the increase in rearing densities. For the conclusions of this study demonstrate that rearing density is critical for both growth and survival of lake sturgeon-free embryos. It suggests that density should be considered when rearing free embryos, since there are multiple facilities that have been exceeding the densities of 21,000 meters squared. And with this paper, we can see that by comparing the data from the study, this density would result in a decrease in total length at emergence. Also, different dissolved oxygen concentrations were associated with different rearing densities. Levels of dissolved oxygen decrease as rearing densities increase, and even though there were differences, the researchers concluded that these were not responsible for the differences in size at emergence. Survival from hatch to emergence decreased as rearing density increased, but there was not much mortality, so the survival to emergence in the study was high. It was set to 96% in all tanks, so no direct effects on survival to emergence were actually associated with the increase of densities. For my personal assessment, I feel like there could have been so much more experimental factors that could be included in the study to see like different results regarding different things. I believe that this study could have a broader range of ring densities since it included very low densities and then jumped into higher ones. The densities in this paper were 50 and then 150 and then 300 and 500. And I think that including different ring densities between the ones used in the paper could have specific results on when the free embryos stop growing in length and start to have lower survival rates, meaning that we could have a more accurate result on when these things actually happen. Other factors that could also be taken into consideration during the study could be the use of different temperatures, water flows, as well as feeding regimens. These environmental factors could have different results and impacts on total length and survival rates. I think that only utilizing dissolved oxygen and different densities can result in poor data. And since the free embryo stage is crucial for the development of the species, maybe a more elongated time frame in the study could be beneficial for the observation of later life stages to obtain data on the long-term effect of ring densities for different life stages, such as juveniles to adults. We could see how these densities affect all these other life stages other than the early life stages. I also believe that a deeper study on the families included in the study could also help understand why there was differences in total length and survival rates for the free embryos encountered, since this paper doesn't really talk much about the differences between the two families or why there was like greater or lower total length and survival for the free embryo stages. Yeah. Thank you so much for your time, and I'll be looking forward for your questions.